Welcome to the Explainer. Today, we are putting together your absolute ultimate Year 8 science survival guide. Now, if you've been staring at a massive mountain of notes lately and feeling, well, just a little bit overwhelmed by it all, I want you to change your perspective for a second. Think of your science exam kind of like an impressionist painting. When you're right up close to it, it just looks like thousands of tiny, completely disconnected brushstrokes. A random fact about a cell over here, a rule about magnetic fields over there. It can seem totally chaotic. But as we take a step back and start to organize all those little details, those tiny brushstrokes of facts actually form a really beautiful, cohesive picture of exactly how our entire universe works. So my goal today is to help you take that step back, see the big picture, and totally master those brushstrokes. Okay, let's dive into this. Here is our game plan for today. First, the ultimate revision strategy. Then, biology, cells and systems. Section 3 is chemistry, particles to reactions. Next up is physics, heat and magnets. And finally, physics, waves and sound.
All right, Section 1, the ultimate revision strategy, working smarter, not just harder.
I really want to kick things off with this incredibly important rule straight from your preparation guide. Do not sit for hours in your room turning pages passively. Honestly, just rereading your notes or staring blankly at a revision guide is kind of like trying to get fit by watching someone else run on a treadmill. It might feel like you're doing something, but your brain isn't actually building any muscle. We absolutely have to activate your memory.
So how do we actually work actively? Well, let's break down these highly effective active revision techniques. First up is the 3-minute blitz. Literally, take a totally blank sheet of paper and give yourself exactly 3 minutes to write down every single keyword you can remember on a topic. Second, the moment that blitz is over, open your notes and use a completely different colored pen to add in whatever you missed. That sudden color contrast is amazing because it instantly highlights exactly where the gaps in your knowledge are. Third, you should definitely use the RAG system, red, amber, green, to color code your confidence levels on different topics. Knowing exactly what you don't know, that is a total superpower. Fourth, when you're doing past paper questions, please don't just peek at the mark scheme. Actually try to complete the paper and then mark it yourself using a different colored pen. And finally, revise together and test each other. Just talking through your answers out loud makes a huge difference.
Moving right along to Section 2, biology, cells and systems, the brushstrokes of life. Let's step right in and see how biology builds a complete working system, starting with digestion. Because your body is literally a masterpiece of teamwork. Food starts in the mouth and travels down the esophagus. Then it hits the stomach for some serious digestion, where it breaks down all those large, insoluble chunks. Then comes a really crucial step, the small intestine. This is where those newly small, soluble nutrients are actually absorbed right into your blood. The large intestine follows that up by absorbing the remaining water. And working incredibly hard behind the scenes, you have the liver and the pancreas producing the vital enzymes that make this entire chemical breakdown possible in the first place. But here's the thought. How do those nutrients, and let's say the oxygen from your lungs, actually make it into your blood? Well, the absolutely crucial point here is diffusion. This is the natural process where particles move from an area of higher concentration to an area of lower concentration. Think about it. When you breathe in, there is a super high concentration of oxygen in your alveoli, so it diffuses naturally across that thin exchange surface straight into your bloodstream where the concentration is much lower. It's just an elegant, completely invisible transfer. Now, what's really interesting is how our cells actually use those ingredients once they have them. We have aerobic versus anaerobic respiration. Aerobic respiration uses that oxygen you just breathed in, combining it with glucose to release a massively large amount of energy, and producing carbon dioxide and water is waste. But let's say you're sprinting really hard and your cells just can't get enough oxygen fast enough, they switch to anaerobic respiration. This doesn't use oxygen at all, and it's far less efficient. And remember, the chemical equations actually change depending on the organism. Animals produce lactic acid during this process, while plants and yeast produce ethanol and carbon dioxide.
Okay, on to Section 3, chemistry. Particles to reactions. Connecting the dots.
Before we can start mixing the paints, we really need to know what our basic colors are. You absolutely must know the difference between these 4 foundational chemistry terms. An atom is the smallest part of an element. An element is a substance made of only one type of atom. Think of pure gold. A compound is 2 or more different elements that are chemically joined together, kind of like water, which is hydrogen and oxygen locked tightly together. But a mixture? That's 2 or more substances mixed together in the exact same space, but not chemically joined at all, like stirring salt into a glass of water. You can easily separate a mixture, but unjoining a compound? That requires an actual chemical reaction. And this brilliantly illustrates how those different elements behave.
When you look at the periodic table, we basically divide it broadly into metals and nonmetals, and they have wildly different physical and chemical properties. Metals are shiny, they're usually solid, and this is crucial for our upcoming physics section. They are absolutely excellent conductors of heat and electricity. Why? Because metals have free electrons that bounce around inside them, constantly colliding and transferring energy rapidly. Nonmetals, on the other hand, generally lack these free electrons, which makes them really great insulators instead. Whether we are talking about combustion, thermal decomposition, oxidation, or displacement, there is one absolute golden rule of chemistry you have to remember. Chemical reactions are simply the rearrangement of atoms. That's it. You are never creating new matter, and you are never destroying matter. You are literally just shuffling the existing particles around into new combinations. And because of this, mass is always conserved. The mass you start a reaction with is the exact mass you will finish with, every single time. Which brings us to Section 4, Physics, Heat and Magnets, Invisible Forces. I want to prime your brain with a super simple question before we talk about heat transfer. Why does a helium balloon rise when you let go of it? Well, it all comes down to one word: density. A helium balloon rises simply because the helium inside it is less dense than the surrounding air outside of it. And this exact same principle drives convection. When you heat a fluid, and quick reminder, in physics both liquids and gases count as fluids, the particles gain internal energy, they start to move faster, and the average distance between those particles actually increases. This means the fluid expands and its density decreases. This hotter, less dense fluid will naturally rise right up through the colder, denser fluid surrounding it. That movement, that actual current of rising hot fluid, is convection transferring heat. Now let's talk about another totally invisible force: magnetism. We classify magnetic materials, things like iron, steel, cobalt, and nickel, into hard and soft magnetic materials. But please do not be confused by the everyday use of those words. It has absolutely nothing to do with whether the material is physically squishy or easy to scratch. A hard magnetic material is simply difficult to magnetize, but once it finally is, it keeps its magnetism very, very well. A soft magnetic material, like the iron core of an electromagnet, is super easy to magnetize, but it loses that magnetism just as easily the exact second you turn the current off. And finally, Section 5, Physics, Waves and Sound, Energy in Motion. We have two main types of waves in physics, and you definitely must know the difference. In a transverse wave, the particles oscillate perpendicularly, meaning at a 90-degree angle to the actual direction the energy is transferring. Think of the up and down ripples on a pond. In a longitudinal wave, like sound, the particles oscillate parallel to the direction of energy transfer, so they don't go up and down, they actually push back and forth, creating distinct areas of high pressure called compressions and low pressure called rarefactions as they travel through the air. Let's look at the ultimate family of transverse waves, the electromagnetic spectrum. It ranges from low-frequency radio waves up through microwaves and infrared radiation, right into the visible light that we can actually see. Past that, we get into the higher frequencies, ultraviolet radiation, X-rays, and finally, those incredibly high-frequency gamma rays. And honestly, the most fascinating thing about all these waves, because they consist of oscillating electric and magnetic fields rather than vibrating physical particles, they can actually travel through a total vacuum. Literally, zero matter. That is exactly how the heat and light from the sun manage to reach us across the sheer emptiness of space. And this brings us right to the mathematical anchor for this physics section. V equals F lambda, or wave speed equals frequency multiplied by wavelength. If you can memorize this equation, and if you really understand your prefixes, like knowing for sure that kilo means times 10 to the power of 3, or that milli is 10 to the negative 3, you will be absolutely ready to calculate the speed, frequency, or wavelength of literally any wave they throw at you on the exam. And there we have it. We've stepped back and we've looked at the entire canvas. You have the ultimate map of your revision strategies. You know the biological brushstrokes of cells, the chemical dots of atoms, and the physics of the invisible forces that animate our entire universe. All the pieces of the puzzle are right there in your hands. So the only question left for you is, how will you paint your masterpiece on exam day? Get out those blank sheets of paper, start your 3-minute blitzes, and I know for a fact you're going to do brilliantly. Good luck.